On July 21st, 1969, humanity set its feet on the moon for the first time. Sending humans to the moon continued for some years, till the Apollo 17 mission in 1972. But we haven't seen any crewed mission to the moon after that. So where are we headed next, and when will we witness this feat again? The earliest discoveries in astronomy are from Babylonians, Greeks, Persians, and Indians. Babylonians first recorded the movement of the moon and sun. Eratosthenes was a Greek polymath and the first known person to calculate the Earth's circumference. The Persian astronomer Abdul Rahman al-Sufi first described the Andromeda galaxy in his book, The Book of Fixed Stars. Similarly, Aryabhatta, an Indian astronomer, assumed that Earth rotates on its axis and that the moon and planets reflect the light coming from the sun. If we fast forward to 1609, Galileo used the first astronomical telescope. He did not invent it himself. The actual inventor is unknown. In 1668, Isaac Newton invented the reflecting telescope, which used a mirror as its objective instead of a lens used in Galilean telescope. But telescopes are used in astronomical observations. What do we use for physical space exploration? Well, rockets, right? The rocket equation, which is usually credited to Konstantin Tsiolkovsky, was independently derived by William Moore and Hermann Oberth as well. The equation was used by Robert H. Goddard in the development of the first liquid-fueled rocket. In the mid-20th century, rockets were much more efficient, and this all acted as an igniter in the space age. But before we jump into the actual stuff, let's try to answer the question, why do we even care about space exploration? Well, we explore it for scientific research, which can lead us to extract resources from other planets, something called in situ resource extraction and utilization. We explore it to expand the limited human knowledge, and we explore it because it gives us insights about the habitability potential of other planets, and more importantly, it helps us to make Earth habitable. What I mean is that it provides us with information if there is something wrong with our planet. For example, the ozone hole was found by an artificial satellite, and that's when we started to take steps which enabled the hole to get smaller and smaller over time. One of the first rocket scientists at NASA, Wernher von Braun, had a motivation, or we can say plan, which we call the von Braun paradigm. NASA has used this paradigm in majority of their projects. But everyone isn't clear about whether the space exploration is really benefiting us, or is it just nonsense. According to an Associated Press poll conducted in July 2003, 71% of US citizens agreed that space program is a good investment, and 21% did not. Space exploration as we see it today began with the space race. Space race, as it suggests, was a race between Soviet Union and United States during the Cold War. It was a way to show superiority by exploring the space and devising new ways for both defense and offense. Soviet Union completed its first space milestones even before NASA was born. Actually, that's what gave birth to NASA. These milestones include the first human-made object, Sputnik 1, to orbit Earth in 1957. The rocket MW18014 was already tested by Germany in 1944. It was a V-2 ballistic missile made by the Nazi Germany during the Second World War. But it was a suborbital flight, meaning it did not attain the escape velocity and thus returned to Earth before orbiting it. Anyway, Sputnik 1 was the first artificial satellite. Its design was quite simple. It was made of two metal hemispheres which were tightly sealed in the form of a sphere. The sphere was polished with a heat shield of AMG-60, an aluminium magnesium titanium alloy. It was launched on 4th of October 1957. The satellite traveled a distance of approximately 70 million kilometers at a peak speed of 8 kilometers per hour. The radio signals from the satellite continued to reach the Earth for 22 days until its silver zinc batteries completely depleted. Before humans were sent into space, the survivability was checked with animals. Many animals were sent into space to check the radiation effects and all. But the first animal to reach the orbit was the dog Laika. Laika was launched aboard the Sputnik 2. The dog died because the technology to bring back the spacecraft did not exist at that time. On 12th April 1961, Yuri Gagarin became the first human in space aboard the Vostok 1 spaceflight. This race continued for some years, but the competition gradually turned into cooperation, as seen in the International Space Station. We'll talk about that later in the video. Now that a human has reached the space, we became eager to know about the celestial bodies in it. The Moon, the Sun, the Mars, all the other planets, and the two dwarf planets, Ceres and Pluto. We completed their flybys by 2015. Venus and Mars being the only planets where uncrewed robotic spacecrafts were landed. But the destinations we were and currently are more interested in are the Moon and the Mars. So let's talk about them. The Moon is Earth's only natural satellite. It has been a major destination in space exploration ever since its notion evolved. Its exploration began with the Luna 2 mission by Soviet Union, which impacted the moon. Luna 1 was the first spacecraft to reach the vicinity of the moon, 5,900 kilometers from it. It was a part of Soviet lunar program. US began its exploration of the moon with Ranger 4 impactor in 1962. After 1966, Soviets deployed a number of landers on the moon, which obtained data directly from moon's surface. US launched its first series of landers, starting with Surveyor 1 in 1966. The Apollo program, one small step for a man, one giant leap for mankind, started in 1960 during President Eisenhower's administration. Its goal was to succeed the Project Mercury, which was a competition to Vostok 1 we talked about earlier. Apollo program later fell under John F. Kennedy's administration, where its goal was
of landing a man on the moon and returning him safely to the Earth.
The goal, which was accomplished on July 24, 1969, with the Apollo 11 mission, when Neil Armstrong and Buzz Aldrin became the first men to step on the lunar surface. 5 more missions took humans to the moon. Apollo 17 was the last among them. Constellation program was proposed in 2005. It was a multi-purpose mission whose goals were to maintain human presence in low Earth orbit, sending humans back to the moon by 2020, and Mars exploration being the ultimate goal. By 2010, the elements required for the Constellation program achieved the preliminary design review, and the test flights were underway. But later on, a committee was formed by NASA. It was named Review of United States Human Spaceflight Plans Committee. I know, quite a mouthful. But do not have to worry, you can also call it Augustine Commission. It was to review the spaceflight plans, which included the Constellation program as well. Many other issues like exploring near-Earth objects, the Moon, the Mars, and moons of Mars were also reviewed. The committee concluded that the Constellation program was behind schedule and any such mission would require more time and funding. The program was removed by President Obama from the 2010 budget. Constellation was replaced by the Artemis program, of which the first mission, Artemis 1, took place in 2022. It was an uncrewed moon orbiting mission. 2 of the Constellation's elements, i.e. the Orion spacecraft and the Space Launch System, or SLS, were added to the Artemis program. Artemis 2 is a crewed mission which will perform a flyby of the moon. It is planned for late 2025. Similarly, Artemis 3 is a crewed mission which will land its crew on the surface of the moon, and it is planned for late 2026. Over time, tidal forces between the Earth and Moon synchronize the Moon's orbital and rotation period. If there are 2 bodies, A and B, with B orbiting A, tidal forces arise due to the difference of gravitational pull of A on the side of B facing A and side facing away from A. The orbiting object, here it is B, is at a particular distance, called the Roche limit from A, then the tidal forces can even disintegrate the body B. So the point is that this synchronization led to the orbital and rotation period of the moon being the same. That's 29.5 Earth days. So it is always the same side of the moon, which faces the Earth. The other side, called the far side, is invisible to us. Apollo 13 passed the far side of the moon at an altitude of 254 kilometers above the lunar surface. Apollo 13 was the 7th crewed mission and 3rd meant to land on the moon. But the mission was aborted after an anomaly was found in the service module oxygen tank when the vehicle was 2 days into mission. Recently, that is in June 2024, China's Chang'e 6 achieved world's first landing on the moon's far side. And not only that, they even brought the samples from there back to the Earth. A similar feat was achieved by India's Chandrayaan 3 in 2023, when it became the first mission to land on the lunar South Pole region. Why is that a big deal, you might ask? Well, the interior of the craters on the South Pole never receive sunlight, so they contain records of hydrogen, water ice, and other stuff, which date back to the early solar system. The crewed missions to the moon stopped temporarily with Apollo 17 and will resume with Artemis 2. Uncrewed robotic missions, however, continue to flourish. I know some of us are obsessed with leaving our beautiful blue planet and going to a rusty red one. Just kidding. Mars as a destination for human exploration and settlement has been in science fiction since the 1880s. You might have watched the movie The Martian. Mars can have habitability potential, and to confirm the same, it is important to know about its topography, atmosphere, and other aspects first, before going there on actual expeditions. We sent many probes to Mars beginning in the late 20th century. Although we did get a bunch of information about its geology and all, but roughly about 60% of the spacecrafts meant for Mars have failed. And that's when scientists talk about the Great Galactic Goal, a fictional space monster between Earth and Mars which uses the spacecrafts as its diet. Mars has 2 moons, Phobos and Deimos. It has polar ice caps and a thin atmosphere. That's why we are preoccupied to occupy Mars. But humans can't live on a planet which has not the conditions similar to the Earth. There is this notion, a hypothetical process of altering the atmosphere, topography, temperature, and other conditions of a planet called terraforming. Carl Sagan, an American astronomer, first described this concept in 1961 for the planet Venus. But there is a lot to research about it, and the ethics, economics, and logistics have to be kept in mind. Due to the specific orbital period of both Mars and the Earth and their alignment with each other, the energy needed to reach Mars varies. For Mars, it is lowest every 2 years and 2 months. That's why we don't launch the vehicles that frequently to Mars. Currently, there are 2 rovers on Mars, the Curiosity rover and the Perseverance rover, with its friend, the Ingenuity helicopter. There are 7 orbiters around Mars: Mars Odyssey, Mars Express, Mars Reconnaissance, Maven, Trace Gas Orbiter, Hope Mars Orbiter, and the Tianwen-1 orbiter. The Rosalind Franklin rover, a joint mission between ESA and Russian Roscosmos State Corporation, was planned for launch in 2020. But the Russian invasion of Ukraine caused a delay, and in 2022, ESA terminated its cooperation with Russia. It is not expected for this mission to occur before 2028. India's Mars orbiter mission was launched in 2013. However, on 2nd October 2022, the probe lost communications with Earth, and ISRO, Indian Space Research Organization, made a statement that the probe was dead. The Mars orbiter mission 2nd by India is planned to be launched later this year. The samples collected by Perseverance rover are planned for a return to Earth by NASA ESA Mars Sample Return mission by 2033. The goal of these missions is to find whether life existed on Mars or not. The moons of Mars will also be explored, so that we can figure out if we can use them as transshipment points for spacecraft heading towards Mars. Before we even think about Mars, we should be aware of the physiological, radiation, and other health-related conditions which may arise in space. And for that, we have established the International Space Station. It also helps us in the health sector here on Earth. Again, the first space station, Salyut-1, was launched by Soviet Union in 1972. 7 more stations were launched under this program. The last module, Zvezda, became a part of Russian segment of International Space Station and is still in orbit. The ISS was given approval by President Reagan in 1984. NASA was all set to find the international partners. At that time, Canada, Japan, and many European nations joined the program. Later on in 1993, Russia was also invited. The development of ISS took place in 2 phases. During the first phase, Space Shuttle carried the crew to the Russian Mir orbital station. The Space Shuttle was a reusable spacecraft which took both crew and payloads to and from low Earth orbit. Each vehicle's projected launches were 100 over a period of 10 years. The vehicle had 4 main parts: solid rocket boosters, external fuel tank, the main engine, and orbiter. The fuel tank was not reusable. 2 of the orbiters, the Columbia and the Challenger, unfortunately suffered accidents with the loss of 14 astronauts. The shuttle gave its service from 1981 to 2011. In total, the shuttle flew 135 times and carried 852 people to and from low Earth orbit. Now back to the International Space Station. 2 modules were developed which became part of the Mir, where experiments and other related stuff was stored. In phase 2nd, every participating nation contributed its elements and crew. There are 5 partners in ISS: the Canadian Space Agency, the European Space Agency, the Japan Aerospace Exploration Agency, the National Aeronautics and Space Administration, and the Roscosmos. Each agency controls and manages its contributed hardware. The ISS was completed in 2011. Recently, news came out that the International Space Station would not be destroyed, but not until 2030. Its initial projected lifespan was 15 years, but it was extended and the station is 25 years old. NASA has selected SpaceX as a candidate to do its job. But what we know is that the current Dragon or Starship are not good matches for that. So SpaceX sure would have to look for something else. The commercialization of space began in 1962 with the launch of a communication satellite, Telstar-1. Later, the space tourism term evolved and many non-professional astronauts flew to space. Voyager 1 is the first human-made object to ever leave the solar system into the interstellar space. Voyager 1 was launched in 1977 and it crossed the heliopause, a theoretical boundary of Sun's heliosphere where the strength of solar wind can no longer push the stellar winds from other stars. That means it entered the interstellar space. As of July 2024, it was 24.4 billion kilometers away from the Earth. James Webb Space Telescope, launched on 25th December 2021, reached its destination 1.5 million kilometers from Earth in January 2022. It is an infrared telescope and it provides information about the first formed stars, galaxies, and also the exoplanets and their habitability potential. Now is the fun part, the alien life. Ever since the advent of space age, this question has been bugging us. There is a whole separate branch called astrobiology which deals with such questions. The major sites we are considering are Mars, Europa, and the exoplanets. And guess what? For every star we see in the night sky, there is a planet or multiple planets orbiting it. That means there are trillions of planets out there. Astrobiology focuses on the biosignatures and the technosignatures. The biosignatures include signs of past or present life in the form of organic compounds or microbial fossils. In 1980s and 1990s, after the discovery of extremophiles, microbial life in extreme conditions like deep-sea hydrothermal vents and volcanic areas, the field research changed. We mainly look for carbon-based compounds because the diversity of carbon compounds is really huge. But theoretical astrobiology says that other organic compounds may exist as well. So nucleic acids may not be the only biomolecules to code for the information of life processes in the universe. Technosignatures, on the other hand, are signs of past or present technology or advanced civilization. These include pollutants and hypothetical megastructures called Dyson spheres built to collect the star's energy. CFCs, the compounds used as refrigerants destroying the ozone hole in the Earth's atmosphere, might be doing something similar on an occupied exoplanet. So searching for that may help in finding the extraterrestrial life, if there is any. One project which will help in search for extraterrestrial intelligence is the Square Kilometre Array. It's a radio telescope which has a collecting area of 1 square kilometer. It is built in Australia and South Africa. SKA will combine the signals received from thousands of small antennas to simulate a single big radio telescope. 16 countries are its members till date. India and UK will develop the computational facilities to analyze the data collected with SKA. SpaceX Starship, the most massive and the most powerful space vehicle ever built and flown, is a fully reusable rocket which aims to continue the human presence in low Earth orbit, sending humans to the moon, Mars and beyond. The super heavy boosters are intended to land on a tower. Actual tower landing is planned for 5th test flight in August 2024. Starship will use on-orbit refueling technique. Remember the von Braun paradigm? Before we wind up, we have to address, in my opinion, the most important thing. We should not go that far in space exploration that we start ignoring our own planet Earth. As the number of satellites in Earth orbit is increasing enormously, space sustainability should be thought of first before planning a mission to space. Alright, I think that pretty much winds up this video. Thanks for watching. I'll catch you in the next one. Till then, take care. Bye bye.